Hello students, welcome back. In this video, we'll begin building Glowfield, a survival game where shrinking light zones are the only source of safety for our player. Players will move through the field collecting orbs to restore the light while avoiding enemies that hunt them in the darkness. If they step outside of the light for too long, their health will begin to drain and they'll potentially die. As the game progresses, light zones will shrink faster, and faster. Enemies will spawn more quickly, and survival space will begin to disappear. The system will collapse as our darkness takes over. In this video, we're going to focus on two main things here. First, our world. What do we want the user who's playing our game to feel as they play Glowfield? We'll set up the aesthetic of our game accordingly. And secondly, we'll create a player object, something the user can control, move throughout the world, and interact with various objects that we place in that world. So let's head over to the computer screen and let's dive right in. All right, so I have a web browser open right here, and I am going to go to vscode.dev to use a web-based IDE. So no software installation needed at all. Of course, if you have an IDE installed on your computer, feel free to use that. You can use one directly. But once I'm here, I'm going to go to Open Folder, and I am going to go to my desktop, which is where we have saved the Glowfield folder. And I'm going to open that folder directly. So we'll click Select. All right, and we can trust the authors. I'm the author, so I think I can trust me. And now I have all 8 of the lessons that we're going to work through open here in our browser. So let's open up lesson number 1. And in here you have 2 files. You have a starter file and a final file. The final file is the completed version of this lesson's code. So you can go through, you can look at it, you can reference it. You can always come back here if you need a little extra help. But we're going to be working out of lesson 1's starter file. This is what we are going to code together to build our game. Now, there's one other thing we have to open up. I'm going to minimize the browser, and I'm going to go directly to that folder on my desktop, Glowfield, lesson number 1, and I'm going to open this file directly in the browser as well, because here is the game in its current state for our starter file. Woof! Look at that. It looks pretty ugly. For a game called Glowfield, it's just like this bright aqua background. Man, I have a player. It looks like he's right here, maybe, this little teeny tiny dot. I'm assuming that's my player. Okay, I can't move horizontally, but I can slowly move vertically. I guess this is a game, but boy, oh boy, is it broken. It is completely broken. So we need to begin fixing it. And the way we go about fixing it, we work here in our code. Now, before we dive into actually writing some of our JavaScript code, let's just take a look at what we have here in this file. This file is called lesson_1_starter.html. This is an HTML document. HTML is the language of the internet, and we are making internet or web-based games. So we're going to be having an HTML file. And we don't need to know much about HTML files, but just know that they're written using something known as tags. A tag is this thing that I have right here inside of our angled brackets, all right? Anything inside of angled brackets is a tag. So you can see I've got an HTML tag, a head tag, a body tag, a style tag, all that good stuff. And information goes inside of tags. So like right here, there is a title tag, and we open a tag, bloop, and then we close the tag when we are done putting information in it. So open a tag, close a tag, open a tag, close a tag. They're like doors. You open a door, you got to close the door. And we put information inside of the door, or inside of the tag. So let's see what happens if I change the information. So I'm going to put, I don't know, let's just put my name in here. I'm going to put my name right here inside of the title. And let's see what happens. So if I come back over to my page here, here's Glowfield. I refresh the game. If you notice, information about the page right here has changed. The text that appears on the tab here in my browser is now Mike. So this just goes to show that when we are working with HTML tags, we can edit the content that sits inside of the tag. I'm going to put this back, though, to Glowfield. I like that much better. Now, let's look here. Right below our title tag, we have a script tag, and this is very powerful. A script tag is where we are going to put our JavaScript code. Our JavaScript code is the stuff we're going to use to actually write our game. So here we're opening a script tag. we're closing a script tag. But we're not actually writing any code here. Instead, what we're doing is we're importing or bringing in a library of JavaScript code, something that's already been written for us that we can use and leverage in our game. And this library has a name. It is called the P5 JavaScript library. So P5. Now what the P5 library is, it's a great rendering tool to create graphics in the browser. And if you think about it, let's just look at what we have here. We're rendering or creating graphics for this little player, for our background, for the text that appears up here in the HUD. To make that easy for ourselves, we are going to use this library right here, this P5 JavaScript library, which is going to bring in some functions that we can use at our disposal. All right. So now let's just keep scrolling down a little bit. So now we've got like a head tag. There's our head tag, right? So open, close. We got a body tag, and then there's another script tag. So this might be where we put all of our JavaScript. And let's see where we close this next JavaScript tag. So I'm going to start scrolling all the way down. Look at all that great JavaScript code. JavaScript, 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 JavaScript. And there, right here, we close our tag. So all of this from line 202, zoop, 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 zoop. Those are sound effects. Zoop, 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 all the way up to line 15 is JavaScript code that represents this particular game. That's where we are going to work and edit. So let's look at what we have in that JavaScript code now. So we have Glowfield, lesson number 1, the world and player. So we have the scope of our game. And then we have something called a mission checklist. We have 8 missions that we are going to solve together. And in doing so, we are going to take this terribly broken game. In case you forgot, this right here is our terribly broken game. And we're going to turn it into a better, more playable version of the game. And in doing so, we're going to learn a lot about computer science, about game development. Now, before we dive into it, let's just look a little bit more at what's in this JavaScript tag. We have something called the student edit zone. The student edit zone is a place where you can safely modify variables. Think of it this way. This is like the knobs and the buttons that you can press in turn to tweak gameplay, to tweak how your game looks, how your game feels, how your game plays, and you will not break anything in your game by changing these values. So if we look here, we've got some, constants. Like we can change the width of our canvas or the height of our canvas or the HUD height or the player size and speed or some colors, all right, or our fonts. But if you look, there is an end to the student edit zone. Once you go beyond the safe space, you could damage the game. You could break the game if you change something incorrectly. And we're going to have to make some changes to things out here, but we're going to change them together so that we make them correctly, okay? So just know right in here you've got the freedom to do whatever you want. Out here, you still got some freedom, but you got to be more careful because you could break the game. So next up, we've got some gameplay variables that we're defining. It looks like we have a player that's defined with curly brackets, and inside of those curly brackets, there's an X and a Y. That makes me think that maybe that's the player's position. But then we've got these things called functions. And so let's just quickly talk about what a function is. A function is a block of code that we can call over and over and over and over again. So if we look here, imagine these 3 lines of code. If I want to run them, I could type them all out. And then if I need to run them again, I could type them all out again. And if I had to run them again, I could type them all out again. But instead, I put them into a function, and all I need to do is run the function itself. So if I run the setup function, all of this code will run. Now, the nice thing is this function is part of that P5 library that we brought in. The setup function gets called automatically at the start of our game. I don't have to call it. And that's a special thing here that the P5 library brings in for us. So when I refresh my game, refresh, right there, this setup function gets called automatically, and it creates a canvas for us. It sets my text font, and then it calls another function known as reset game to defaults. We'll look at that later. We also have a function that's from P5 called the draw function. This gets called automatically every single frame of our game. So every single frame, that function gets called. Now, what's happening here? Well, it looks like we're updating a player and we're drawing our scene. Okay, so Where do these other functions live? Well, if we look, we've got a function called reset game to defaults, a function called update player, a function get input direction, draw scene, which looks like it has like draw background, draw player, and draw HUD. Okay, so there's all of our functionalities. So it seems like our functions have like a couple of scopes, right? Some functions draw stuff to the screen, they render graphics. And some functions maybe like update data. All right, so that's pretty good. And maybe other functions are like defining data. So like we're defining the player's X position, the player's Y position. And here we're defining a bunch of data up here. So we're really going to try to break down game development into 3 specific layers. Layer 1, define your data. Layer 2, update your data. And layer 3, draw your data to the screen. So we've got to define our data, then we update it, make changes to it, and then finally we give some visual feedback to the user by drawing that data. All right, so now that we have some familiarity with what is in one of our HTML files, let's start lesson number 1 here. Let's go through our mission checklist. We want to solve mission number 1. It says change the background color of the field. Yeah, I agree, because it looks terrible. For a game called Glowfield, this doesn't really fit the mood I am trying to go for. So what we're going to do here is if you hit Control F or Command F, you'll bring up the search bar right here. So just if it's closed, hit Control F. And we can search for the Mission 1 tag. So I'm going to search Mission 1 because it appears here in the mission checklist, and then it only appears one other place in the code. So if I hit the down arrow, I will find the next match. And that brings me right to where mission 1 needs to be solved. So here's our mission checklist, and then here is where mission 1 is in the game. Mission 1, our background color, says change the background color of the field. Observe how it changes the mood of the world. So where does this live in our file right here? Well, if I scroll up just a little bit, it's in our student edit zone. This is the place where we are safe to modify some of our gameplay constants. So let's modify it. If we look here, this line has 3 parts to it. Const, then it has BG color, and then it has this weird looking thing inside quotations. Let's just quickly go over what those things are. A const is a constant variable. If something is a constant, it means that once you define it, it will not change its value throughout the scope of where it is being run. Now we're running it just here in the main code, so once we define it, we're never going to change its color. Once I run the game, the background color is never going to change. It's not going to go from like green to red to blue, all right? So I can define it as a constant. And then the variable name is all in capital letters. That's an indication that this is a constant variable. Anytime we work with constants, we typically make them all uppercase. So I called it BG underscore color. And then we are assigning that variable a value with an equal sign, and our value is this thing inside of quotations. Anytime you have something inside of quotations, it is known as a data type called a string, and we'll talk about strings quite a lot as we work through this game. But this is a special string. It's a special string that leads with a hashtag. This is known as a hexadecimal string. I spelled hexadecimal wrong. I always do that. How do we do it? Let's see. If I just hover view problem. Yep, it's telling me I spelled it wrong. Watch this. I'll fix it. Hex string. This is known as a hexadecimal string. A hexadecimal string is a way that we can represent colors. And this is really made up of 3 colors. It is made up of red, green, and blue. And if we mix red, green, and blue in any proportions, we can make any color that we want, even this aqua color. So how do we do it? Well, you get 2 digits for red. So our red right now is 44. All right, we get 2 digits for green. Our green is E8, and you get 2 digits for blue. Our blue is E1. Now, you might be sitting there going, wait a minute. Digits, those are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I know digits, but we have letters. We have E, and we have, look at this, E. So what is this? Well, we're dealing with hexadecimal values. Normal numbers, decimal numbers, use 0 through 9. Hexadecimal numbers have more options. They have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 10. They have 11. They have A. They have B. They have C. They have D. They have E. And they have F. So what do those letters mean? Well, if we look up here, they just match to the next numbers. So A is 10. B is 11. C is 12. D is 13. E is 14. And F is 15. So what comes after F? Well, after F, we've run out of digits. So just like when we ran out of digits here at 9, we went to 1, 0. So then we would go to 1, 0. And in hexadecimal, that is 16. And so what we can do is we can use hexadecimal numbers to tell the browser how much red do we want in a color, how much green do we want, and how much blue do we want. The maximum value here that we could pick is FF, and that corresponds to a digit of 255. The minimum number is 00, and that corresponds to 0 of that color. So let's build a new hex string. I'm going to get rid of all of that information so we don't crash our program. Let's build a new hex string. Let's just start by making, let's do 0, 0, no red, 0, 0, no green, 0, 0, no blue. So let's just see what this looks like. Hey, no surprise there. It's black. Hey, that's kind of cool. Okay, we have none of it, none of the colors. Let's give ourselves all of the red. So we'll put FF in for red. Hey, that's a really bright red. I like that. Let's add some all of the green. So what's red and green going to make? Whoa. Cool, it makes yellow, but that's a really bright yellow. So what we can do is we can sort of lower these values. Let's do AA. So I'm going to get less red and less green. Oh, what did I do? I put too many digits in. There we go, AA and AA. All right, and so that's like a duller yellow. Okay, so that looks kind of cool. What if I just do, let's do like a little bit of red, so 3, 3, a little bit of green, 1, 2, and a lot of blue. So I don't know, maybe like D3. So now this should be a primary blue color. Ooh, that's actually pretty. I like that. What happens if I do all of everything? So let's do FF, all the red, FF, all the green, FF, all the blue. Ooh, I get white. So if I mix all the colors together, I get white. All right, so now that we have an understanding of hexadecimal strings and how we will use them to define color, let's set our background color. I'm going to have just a slight bit of red, so 0B, just a slight bit of green, 06, and then more blue, so 20. So not a lot of color in any of those channels. So this is going to be a pretty dark color, and it's like a really dark navy blue, and I like that. That lends to this idea that there's going to be darkness creeping in all over our battlefield. Mission 1 is complete. Not only did we do it, but we learned all about hexadecimal colors. So now in our search bar, let's change it from mission 1 to mission number 2 to see where we are. Mission number 2 tells us we need to look at player position. It says position the player in the center of the playable area. Okay, so let's see, because it looks like when we start our game, where do we start? Oh, we start all the way down here in the bottom right corner. That's not what we want. We want to start zoop right here in the center of the game. So if you notice, this puts us in a function called reset game to defaults. So anytime we start our game, reset our game is in this starting position, we are going to call this function to sort of put the game back in its starting state. And if you look in the setup function, which is given to us by the P5 library that we're bringing in, this gets called automatically once whenever we start our game. So it just got called, it just got called, it just got called. We are creating a canvas, we're setting our text font, and then we are calling that function right there. So we're always going to reset our values. So what are we resetting? We're resetting our player object. Why is this an object? Well, it's inside curly brackets. And objects have properties. You set the property name, and then you give the property a value. So if we look, we're setting the property of its x position to 0 and its y position to 0 when we define the data. Then when we go to reset game to defaults, it looks like we are updating the data. We're taking that variable player and we're accessing its x property. And it looks like we're doing width minus 100 and its y value we're doing height minus 100. Well, that's not right. Well, let's just change it to, I don't know, let's change it to 100 and 100. So now when we restart the game, where's our player go? Well, our player goes 100 pixels in. So this top right corner is 0, 0. So we go 100 pixels in, and then as you go down, you increase in y value, and we go positive 100 pixels down. And I could change this. I don't know. Let's make it like 500 and 300 or 200. All right, so we're sort of getting closer to the center. Of course, I don't want to keep guessing and checking. Instead, what we're going to do is we're going to use our canvas object. So we created a canvas, and the canvas has a width and a height. So to center the player horizontally, I'm going to use the width of my canvas divided by 2. So now if I refresh the game, the player is centered completely horizontally. I now want to center the player vertically. So we could just do, let's try the height of our canvas. You guys spell height right, height divided by 2. And this is going to get us pretty darn close. But where this is centering us, it's centering us in the entire window, right? Our entire canvas. But I want to center the player in the playable area. We're not going to use the HUD as a playable area. So really, I need to shift the player down a little bit. And I'm going to shift them down by the height of this HUD to center them in our playable area. And if I go to our student edit zone in my gameplay constants, you can see I have a variable called HUD height that has got that set. So I'm going to add the HUD height variable to this. Now when I do that, I want to make sure I use order of operations. So I'm going to add HUD height. So I'm going to put that in parentheses. So we add it and then divide that sum by 2. And now when I refresh the page, the player is shifted down appropriately and they are centered in our actual gameplay area. All right, mission number 2 is complete. You guys are doing great. We're making great progress. Now we want to make the player glow orb a little bit larger. So our player right now is super, super teeny. And if we look at mission number 3, we have a variable called player radius. It's currently set to 4. Yeah, that makes sense why it's super small. So first off, we're calling it player radius because the shape of our player is going to be a circle. And so the radius is from the center of the circle all the way to an edge. And so right now it is set to 4. Let's up it. I don't know. Let's make it like 50. What's our player going to look like if we do that? Whoa, that's a little bit too big. Okay, that's a little bit too big to move around this battlefield. But this will show the radius is here from the center all the way to the edge. Center all the way to any part of the edge. Let's change it to, I'm going to set it to 14. Let's see what that looks like. All right, that looks better for me. I like that size. Maybe you want to change it. This is up to you. You're in your student edit zone where you can have the freedom to change whatever you want. All right, mission number 3, done. Mission number 4 says we got to change the player's visual identity. We're going to change the color of the player. And yeah, that kind of makes sense because to me, the player sort of looks like, I don't know, a watermelon right now. It kind of looks like a watermelon, not the vibe I'm going for. And so if we look here, we've got 3 different colors we're going to work with for the player. We've got the player's body color, their accent color, and then it says the pupil color. Okay, well, the player color right now, the body color, if we look, what do we have? We have F0, so a lot of red, a little bit of green, and a little bit of blue. And so that's that like watermelon red color. I do not like that. Let's get rid of that. And let's think about what color we want the player to be. So maybe you're going to pick something different, but I'm going to pick a little bit of red, 1E, a little bit more green, but still not a lot, 2, and then a little bit more blue, but still not a lot, 3, 0. All right, and so that kind of blends in with that background just a bit. It stands out, but it blends in, and I kind of like that. It sort of gives the idea of the player has some darkness to it. And then we're going to set this accent color, and the accent color is what's going to pop here. And so my accent color, I'm going to do 3B, so some red, a lot of green, E7, and just a ton of blue, FF. So a lot of green, a lot of blue. This should give me a really nice cyan color. And there we have it. So I like that quite a bit. In fact, let me up the player's size. I don't know, just so we can see it. I'll up it to 50. Ooh, that's starting to look pretty good. That's starting to look really good. And then I have this player pupil color. Now, if you notice here, the player's pupil color is not defined with a hexadecimal string. Instead, it's defined as an RGB alpha string, an RGBA string. And the idea is still the same. We have 3 colors, red, green, and blue, but then we have an alpha channel, which is what we would refer to as its transparency, and that is going to be between 0 and 1. So here we're using decimal numbers, so we can work with 0 to 255. So just like if there was like an FF up here in the red channel, we would put 255 here. So we have red, green, and blue, and then this number, which is between 0 and 1. That is its transparency, how much you can see behind it. If the transparency is set to 1, it means it is not transparent at all. You're not going to see behind it at all. And if the transparency is set to 0, it is fully transparent. You will see completely behind it. So what I'm going to do is I'm going to change these values. I'm going to have a black eye, so 0, 0, 0, a black pupil, and I'm just going to give it a slight transparency, so 0.72. Anytime we need a color that is transparent, I will use an RGB alpha string. So if we refresh the page, ooh, look at that. There is our transparent eye right there in the center. So look, if I lowered this to like 1.2, you're going to see behind it a lot more. You can see, it's much more transparent. But let's change that back to 0.72. And I'm going to change back my player size to what we had it to. I think it was 14. Yeah, I'm going to put it back to 14. All right, so now our player looks much, much better. Oh, look at that. Look at that little guy. He's fun to control. But not really. He's not fun to control yet because all he can do is move up and down and move extremely slow. So we got to move to mission number 5. Ooh, mission number 5 is all about the player's speed. We just said he moves super, super slow. So we're going to increase the player's speed and observe how movement responsiveness changes. And right now, our speed is in something we will refer to as pixels per frame. It's simple, and it's great for us starting out, but eventually we'll move to a time-based system rather than a frame-based system. Right now, the player's speed variable is set to 1. I'm going to make it 4 so we can move 4 times as fast. Let's check it out. All right, that feels much more responsive. I like that quite a bit. But there's only one problem. I only got vertical motion. I can't move horizontally. Bad gameplay. So we got to fix that. Let's see. Mission number 6. Is this gonna get us there? It is. We are going to begin to fix it right now. Mission number 6 is about input connection. We need to connect when the user presses the keyboard to movement in our game. And so this is inside of a function called getInputDirection. So let's look at what we are maybe doing here. We're declaring 2 variables, dx and dy. And if you notice, they're being declared with the word let, not with the word const. Because inside of this function, these variables are not going to be constant. We are going to change these variables. So we declare them with the word let. dx represents the direction that we want to change in the x direction. So if it's at 0, it means we don't want to change at all. If we make it maybe positive 1, we want to change to the positive x direction or to the right. If it's negative 1, we want to change to the negative x direction or the left. Same with dy. If it's 0, we don't want to change at all. If it's negative, we want to go up. If it's positive, we want to go down. Remember, down is the positive direction for the y here. And so let's look at what we have here. We got to ask the question. We got to ask the program to say, hey, is the user pressing a key on the keyboard? And if so, we're going to do something. And if you look here, we've got this set up for our vertical direction already using an if statement. An if statement is going to ask a question. And the question goes inside of these purple parentheses that I have here. And if you look, our question has 2 parts to it. It's asking, key is down, which is a function. So is a particular key getting pressed down? Key 87. And then these 2 vertical bars mean or. Or, we're calling key is down again, is another key being pressed down, the up arrow key. Our arrow keys are super special. They have names that we can reference directly. This 87 is a key code for the key W. So every key on your keyboard has a key code. W's is 87. So we ask a question, hey, if the answer to that question is yes, then we are going to run this code over here. So, hey, check to see if the W key is pressed, or check to see if the up arrow is pressed. What's the answer to that question? Is it yes? If it is yes, what do we do to our dy variable? Well, it was 0, so then what we do here is we subtract 1 from it. That's how we do this. Minus equals 1 means subtract 1 from it. And so now 0 becomes negative, or dy becomes negative 1. We ask another question. If key down 83, that is going to be our S key, or our arrow key is being pressed, so down or S, then what do we do? Well, if the answer to that question is yes, we're going to take that dy variable, instead of subtracting 1, we're going to add 1 to it to indicate that we want to go in the downward direction. So we got to ask similar questions here, but we're going to ask similar questions for horizontal movement. So let's see how we would do that. So I'm going to start by asking a question, if, and a set of parentheses. And then I'll put my question in here. I'll say key is down. So I'm going to do the left arrow keys first. So the left arrow keys, and we're going to do left and A because we'll have WASD movement. So we want to figure out the key code for A. The key code for A is the number 65. So is the A key pressed, or key is down? Is the left arrow key being pressed? And if that answer is yes, then what do I want to do? Well, the player wants to move to the left, so I want to change my horizontal direction. So dx, instead of being 0, I'm going to subtract 1 from it to make it negative in the negative direction. So I'm going to say dx minus equals 1. And now we have to do the same thing for rightward movement with the right arrow key or the D key. So if, here's our question, key is down, and we're going to put in the key code for the letter D, which is 68, or 2 vertical bars, and we're going to check to see key is down, and then we'll put in the right arrow. Now that means they want to move to the right. So now instead of making dx negative 1, we're going to make dx positive 1. Hey, all right, so this is pretty good. So let's check. Do we have rightward movement? Oh, my game is broken. I must have made a mistake somewhere. Let me debug this here for 1 second. I see it right away. I wrote left arrow. We got to have left arrow, all right? So our spelling really matters here. It really matters. And there we have it. So now I have horizontal movement. That's pretty good. All right, so I have vertical movement. I have horizontal movement. Great, great, great. Where'd my player go? Where'd the player go? I guess the player can go right off the screen, which is not good. So in the horizontal direction, we can just disappear. So let's just see, what's happening now. So before we go to mission 7, let's look here. This is really special. At the end of this function, so we set these dx and dy variables, we check for keyboard input, we change them, and then we're returning, look at this, what we're returning. We're returning dx and dy, and we're bundling them up as an object. So we're returning them somewhere. We're giving this information back to someplace. So if I just scroll up a little bit, I have the update player function. The first line in my update player function, we are calling that get input direction function. And so when I call this function, I am going to be returned some information. Some information is going to get returned to me. My dx and my dy variables are coming back to me. So I know what direction we want to move in. And I'm taking that information and I'm storing it in a variable called move direction. So if you look, that move direction variable has a property. It has a dx property. That move direction variable has a property, the dy property, and I can access them. And that's exactly what we're doing here. So that is the idea of return values, which is super important. Now, where is this update player function actually being called, which is like actually moving my player? Here we're updating the player's position. Well, remember, the P5 library gives us some default functions. It gives us a setup, which runs once at the start of our game, and a draw function, which runs every single frame. So every single frame, that update player function is getting called. And then we're also running a draw scene function, which we'll talk about shortly. All right, so let's go back to mission 7 here. It says we need to set a world boundary rule. We have to keep the player inside of the playable area so we can keep them from leaving the battlefield. And so to keep the player from leaving the battlefield, we are going to constrain the player's location. The constrain function does something nice for us. It takes a value and it guarantees that it's between a minimum and maximum value. If it goes too low, it stops it at the minimum value. If it goes too high, it caps it at the maximum value. So we're going to take the player's X position and we're going to constrain it just like we have for the Y position, because that's working nicely. So constrain. And what value do we want to constrain? We want to constrain player.x. And then let's just try to say, all right, the smallest value is maybe 0, and the largest value is the width of our canvas. Let's just see how this works. So if I refresh the page, I zoom over. So right here, I should get stopped. And I do, but I'm sort of like halfway off the canvas. And that's because our X position is the center of our circle. So we are constraining the center of the circle. I don't want to do that. I need to push the player back in a little bit, like the radius of the circle. So I got to push the player back in by like the player radius. So 0 maybe plus the player radius. And so when I do that, that should give me some nice constrained movement here. Oh, perfect. So now I'm stuck. But on the opposite end, I have the same problem. So now I need to shift back the player radius. So the width minus the player radius. And with that, we are properly constrained so that we cannot leave the battlefield. We are stuck to move around the battlefield at all times. And we got the proper constraints in the Y direction earlier. All right, folks, we are making wonderful progress. I think we said we had 8 missions. We just did mission number 7, so there is only one more left. Mission number 8 brings us to the draw HUD function. Our HUD is this region right up here where we'll display information about our game to our user. Right now, we are just displaying some text. So let's take a look at what we're doing in the draw function. Now, our draw HUD is getting called right here inside of draw scene. We know that this gets called every single frame due to it being in the P5's draw function. We draw a background, our player, and our HUD. And if I comment any of these things out, right, if I'd say, hey, let's not draw the player, watch this. Boom, my player is gone. If I say, hey, don't draw the background, boom, our background is gone. I want to draw those things though, okay, so I'm going to bring those back in. So we are focusing on draw HUD. What are we doing here? Well, the first thing we're calling is no stroke. When you draw things to the screen, think of that like you have a marker, all right? So you have a marker and I want to maybe draw a shape. So I want to draw a rectangle. So I use the marker and I draw the edge of the rectangle. The edge of that rectangle is going to have a color unless you call no stroke, which says, give me an invisible marker. You will not see the outline. Then we use fill to load up, I like to say load up paint in our paint bucket. So I load up my paint bucket with a color, the HUD background color. If you look, it's an RGB alpha string, 000 with some transparency, so a transparent black. And then we draw a rectangle. A rectangle, when you draw it, needs 4 pieces of information. The upper left-hand corner, 0, 0, so that puts it right here. And then the width of the rectangle and the height of the rectangle. The width is the width of our canvas. The height is our HUD height. So it draws a rectangle right here for me. The paint is in our paint bucket, so it fills it in, and our marker is invisible, so there is no outline. Now we load up a new paint in our paint bucket. We load up the text color, which is going to be, if we look at that, a lot of red, a lot of blue, a lot of green, a lot of blue. So it's basically going to be like a white. And then we align our text. How do we want our text to sit in our space? You align horizontally. So we're going to say align it to the left, and vertically, right in the center. And then we're setting our text size. We're setting the size to be 18. So let's just look like I could change the, I don't know, the size. Let's change the text size to 50. Whoa, doesn't look good, but it changed it. So I'm going to put it back to, what was it, 18. So what we're going to do next, now that our text is set, we want to change the actual text by calling the text function. We got to give a real name to our game. So I'm going to change the text here. When you call the text function, it takes 3 pieces of information. The string that you want to render to the screen, its X position and its Y position. So let's change all 3 of them right now. I'm going to change the string to say Glowfield, the name of our game. And then, I don't know, what if I change this position to be like 600 and this position to be 400, the X and Y positions. So it puts Glowfield way over here, 600 pixels in. So that's going to be right at the left because it's left aligned. And then what was it, 400 pixels down, all right, and that's going to be center aligned. But we don't want that. We want it back in the HUD. So let's change it back. What did we have it to? We had it to 25 and 15. All right, and so with that, our HUD identity looks correct. Our game, our world is set. We have this eerie, dark background. Our player looks pretty cool. He's kind of got this like neon glow to him on that darkness, and he can move all around the battlefield with constrained motion. I think this is wonderful. We did a great job solving our 8 missions and taking that broken version of this game that was really bad looking, right? That bright like aqua color. And we made it something that is much better. It sets the mood of our game appropriately, and it gives us something that we can control. Our player object is coming along really great. I think this is a great place to stop, and I'll see you in the next video.